Hello guys, in this video I'll be discussing the action potential graph, and so let's get started. We have the cell here that has a resting potential of negative 70 millivolts. Various cell types vary, so like the heart has like negative 90 millivolt resting. And so there's various factors that affect this resting potential, such as potassium leak channels and the sodium potassium pump. The sodium potassium pump, you want to know that it pumps two potassiums in and three sodiums out. And that's going to be energy dependent. And the reason why that's energy dependent is because you have a high concentration of potassium inside the cell and a high sodium concentration outside of the cell. So in order to be able to move something against its gradient, you'll need to basically use energy. So sodium is high outside, so you naturally don't see it going back outside, so that's why you need ATP. Similar to potassium, it's high inside, so you don't see it naturally going back to where it's highly concentrated, so you need energy to basically bring it back. A good way to remember that potassium is high inside the cell, the way I remember it is you text somebody on your cell phone saying K, if that makes any sense. And that's how I remember that. And so there's a threshold value, which is basically the value needed for the cell to fire an action potential. So if there's enough positive ions that enter the cell, and it basically changes the polarity, and the cell is basically fires its action potential. So the movement of sodium ions inside the cell causes what they call an excitatory post-synaptic potential, which is meaning that the cell is excited, but it doesn't necessarily mean that it's going to fire an action potential because the signal could be weak, right? So that's why here you see the stimulus of value, whatever. Those are failed initiations. That means that you had excitations, but that were not strong enough in order to reach threshold value. But there could be various ways that like these values that are not at threshold generate an action potential by various mechanisms, such as temporal summation and spatial summation. Temporal summation is when you have a sequence of excitations very rapidly in a short amount of time that integrate, and basically the values join together to reach threshold. And spatial summation is where you have a bunch of excitations that basically fuse together and reach threshold and fire, and then the action potential is fired. The location where the action potential is generated or initiated is known as the axon hillock. It's the junction between the cell body and the axon, and it's the thickened portion. So once the threshold value is reached, the cell depolarizes. The opening of the sodium channels causes a change in polarity. So from negative on the inside of the cell, then it becomes positive. And then at this value of positive 35 in this cell type, the sodium channels will close at the peak, and the potassium channels will open. And since potassium is high inside the cell than outside, potassium will leave the cell due to its concentration gradient, right? And it will go down and repolarize to attempt to go back to resting, right? But the issue is that the potassium channels close very slowly, and therefore it will cause the cell to go even further than usual, so more negative than usual, and that term is known as hyperpolarization. And so once the cell has basically been able to close these potassium channels back to normal, and the sodium potassium pump's activity, the cell will be able to go back to resting. So the potassium leak channels and the sodium potassium pump are going to play an important role there. A lot of times I get asked, how come the cell is negative when these are positive ions? The reason that is the case is because when the electrode is placed, it's measuring the difference. So the membrane potential is the difference within the outside and the inside. So it's like taking minus 2, 2 minus, sorry, let's say we take positive 2 minus positive 3, right? We get a negative number. That's the idea. Thank you for listening. If you have any questions, please send them in. Don't forget to please subscribe, share, and comment if you have any questions.